Hi, Tom English again. We're talking about right triangles in geometry, and brings up a whole new type of math that we call trigonometry. And basically what trigonometry allows us to do is find unknowns without having to find two triangles and making them congruent to each other. If we can put that unknown, whether it's the height of a ladder or a wall or a distance kind of thing, in the form of a right triangle, then we have these trig functions that allow us to find those parts of the right triangle. First of all, let's start with the concept that all right triangles, you want to have some convention of how you label these triangles. I've just drawn three right triangles up here, and notice the different orientation and so forth. So often you see, let's say the first version here on the left, and if the triangle's turned, kids get confused, say, oh, I don't know, where's the right angle? And this is the point. You need to, first of all, if you know it's the right triangle, find that right angle, and then the convention is that that vertex at the right angle usually is C. If we label our three vertices, A, B, and C, we want to choose C for the right angle, and then it usually went in a, it doesn't really matter, A, B, C, clockwise or counterclockwise, but you'll notice in every case here, C is the right triangle. And then the other convention is that usually the vertices are a capital letter, and the sides then are the small letters corresponding to that. For instance, in this case, the side opposite the vertex A is a small a. The side opposite the vertex C is a small c, and of course B, the small b. So those are conventions, because then when you start looking at ratios and so forth, you'll understand where they came from. The three functions within trig that we are going to study are the sine, the cosine, and the tangent. And each of those represent a particular ratio. For instance, with the sine, we're saying the sine of an angle, this is angle A, is equal to the ratio of the opposite side over the hypotenuse. And that's something you just need to burn into your mind. Opposite over the hypotenuse. In this case, when we look at the letters that we've assigned to the sides, the side opposite would be A, and the hypotenuse would be C. So we say that the sine, we abbreviate SIN, the sine of angle A would be A over C, opposite over the hypotenuse. The cosine is the adjacent side. And by adjacent, we mean it forms part of the angle, doesn't it? It's one of the sides of the angle. So the adjacent to angle A would be the letter B, or side B, and the hypotenuse is still C. And then finally the tangent of angle A is the opposite over the adjacent. It doesn't use the hypotenuse, it uses the two legs of the right triangle. Now, the way you would do this, let's give some, let's take a triangle, and I'll just make it nice and convenient that it happens to be a 3, 4, 5 right triangle. And here's the right angle. So, if that's the right angle, that would be C, and this would be A and B. Okay? So, if we say the sine of angle A, we're saying the opposite of A would be 3 over the hypotenuse, which would be 5. Now the question is, how do we find that angle? What is that angle? Well, in this case, we convert it to a decimal, 3 over 5 is equal to what? 6 over 10, which would be 0.6. And then I won't tell you now, but we'll get into how we take our calculator and convert that in to find out what the degrees in angle A. Another problem, let's say, would be, let's say we know the angle, and then we have to find the sides. And it used to be you had to look it up in a table in a book that was pages long, because it had for each degree possible, it would have the 5-digit or 5 decimal place number for the value of that angle. In this case, with our calculators today, it really makes it simple to do. But for this lesson, let's just again zero in on, let's say we're going to have the cosine. The cosine, let's pick a different angle. Let's pick angle B. Okay? The cosine of angle B, well, we're now looking at from B, and we know the ratio for the cosine is the adjacent over the hypotenuse. Okay, if we're looking from angle B, it says the adjacent, so it would be what? A over the hypotenuse, which is C. Okay, let's go back to this one. Again, we're saying we're dealing with angle B, so therefore the side adjacent, in this case again, would be A, and over the hypotenuse, and the hypotenuse is always C. So we're going to use those ratios to either solve for the angle itself or to solve for one of the sides. Maybe we know the angle. For instance, let's say, let's just make this up, and let's say the cosine of angle B, and B happen to be 30 degrees, is equal to A over C. Well, if we're given C is 5, okay, what we would do in our calculator, if we were to solve for A, what do? Well, we have to multiply both sides by C in order to get A by itself, right? So another way to write this would be A is equal to the letter C times the cosine of angle, whatever, in this case is 30 degrees. And with the calculator, we put in cosine, we put in 30 degrees, it will come back with a decimal value. We multiply that by C, and that will give us A. So, a little confusing right now, but we're going to come back and put some examples in here, put some values in, and we'll see how to solve either for the angle or one of the sides. Thank you.